All right, let's go ahead and get started. So today we're going to be continuing 3.6 on equivalent Boolean expressions, and we're going to continue where we left off. Last time we set ourselves up to solve the first homework assignment, which is example 3.6.5. And for that assignment, we needed to come up with two different equivalent Boolean expressions. One for the first one that you see over here, that's cannot ride. And if you take a look at the slides, this is what we came up for that. So we were given the statement on the left, and we went through the steps to convert it to the statement on the right. And then we also did the same thing for cannot swim. And you can go ahead and see that one as well right here. So we were given the one on the left, and we went through the steps of De Morgan's laws to come up with the one on the right. Okay, so now that we have those conversions, you'll notice that all you have to do for this homework assignment is to actually make those changes in the code. So let's go ahead, and if you see this link right here, right here, you can click that to join me in a collaborative coding space where we can work on the solution together. So I'll go ahead and put that in the chat as well. So I'll go ahead and click on that link, and then we can solve this. All right, I see some of y'all are now in this coding space. So the first thing we're going to tackle is we'll look at this first chunk that has a comment, and it says convert this Boolean expression into its De Morgan equivalent. So what I'm going to do is I'm going to comment this out so we still have that to look at. And then I'm going to go ahead and on the next line, I'm going to put Boolean cannot ride. And let's see, RV, I see your name first. So can you type the equivalent Boolean expression for that first one that we came up with on that line? Awesome, yeah. So RV went ahead and put the not symbol on each Boolean expression or each Boolean component, and then flipped the and to an or. Awesome. So that's going to work for that one. Now let's go ahead and change this one. So this is the second Boolean expression that we need to find the equivalent to. Yeah, 1 second, okay. So here's the collaboration link. There you go. And so I'm going to do the same thing. I'm going to comment out the original Boolean expression, and then we're going to set ourselves up to write the equivalent one. So let's see, I have a volunteer to type the next one on line 45. Let's see, Jason, are you able to do it on line 45? Awesome. So Jason went ahead and applied De Morgan's laws correctly, brought the not symbol to each of the Boolean components, and flipped the or to an and. Awesome. So what I'd like to do, I want to check this work. So I'm going to copy it. And at this point, come back and look at my shared screen. Because what I'm going to do is I'm going to use the tests that are on this actual assignment. Oops, let me get this Zoom stuff out of the way. All right, so I'm going to click on the actual assignment. Click on Let's Go, and let's paste this baby in. And let's run the code. I'm going to enter 12 and maybe 60. And then let's say true and true. Okay. I realized that you actually don't have any tests for this, but this is the correct solution. We use De Morgan's laws to convert those Boolean expressions to their equivalents. And so you could do the same thing. You can go ahead and copy the code from our collaborative space here into the assignment, and then you should be able to say submit and continue. All right, let me know if there's any questions about that one. And I'm going to go ahead and put the Pear Deck link in the chat in case you weren't here when I posted that in the chat. Because we're going to use the Pear Deck now to set ourselves up to complete the next one. So this is exercise 3.6.6, and it has to do with odd numbers. So in this program, it's expected that the user is going to enter in 2 integers, and then based off of that, it's going to determine if the user's 2 numbers are both odd or both even. Oh no, that's the next one. This is just both odd. Sorry, I got anticipated 3.6.7. Okay, so it's going to determine if they're both odd. Okay, the program computes 2 Boolean expressions in order to determine if the equivalent De Morgan expression gives the same result when checking for odd numbers. Okay, this is the expression given in the code. So this one that says both odd right here. This one right there. What we want to do is convert this piece right here to its equivalent. And it looks a little different than the ones that we've done before. But I think we can do it. I've written out some steps here. So give it a shot. Look at the steps. It says, see the common not. So this not right here. Move it outside the outer parentheses. Notice that they didn't have parentheses here. I added some in to visually help you see the component. So this is one component. This is one component. And then I grouped that whole thing in parentheses. So I want you to move that not outside of the outer parentheses. And that means that you're going to have to change this not equals to something that makes sense. So what do you think the opposite of not equals to is? You can make that change. And then finally, you're going to flip the and to an or. So give that a try. All right. Looks like everyone gave this a really good try. Some of you might still be working as I'm looking through this, but let's go ahead and take a look. Let's take a look at one person's, maybe a couple people's responses. So come on back to my shared screen and let's take a look at some of these. Let me clear my annotations. Okay. So I said for the first step that we wanted to do is we wanted to find that common knot, which was this right here, knot on this side, on the left side, and the knot over here on the right side. And we wanted to move those both to the outside. Bam, that way. Okay. So this student went ahead and did that. You can see the knot right here. And then I asked you, what's the knot equals going to change to? Some of you just left it as a single equal symbol, but remember that means assignment. That is not a comparison operator. Instead, you want to put the double equal symbol, which means that we're looking for equivalence. So not equals is the opposite of double equals. So when you're taking out that not, you're going to flip that to the opposite, which is the double equals. Okay, so that's good. That's a good first step. But then we're not done yet. We need to flip any ands to ors and any ors to ands. And so this student saw that there was an and here and went ahead and made the change and flipped it to an or. So now the final answer is right here. And that's a really long final answer. So not uh, num1 mod 2 is 0. So basically this is saying that num1 is even, essentially, and then num2 is even, and then you not that. You take the opposite of it. Okay, so you're checking to see if they're even, and then you are then taking the not. Okay, and that will give you whether or not they're both odd. Okay, any questions on that one? Hopefully those steps made sense to you, and I know that this one looked a little bit different than the ones you normally see, um, but you can still generalize those same steps of moving out the not and flipping the and and the or. All right, so let's go ahead and look at this in terms of, oh, and here's kind of like the solution written out, and I highlighted the parts that changed at each step. Okay. So basically what we're going to wind up with is we're going to go ahead and use that equivalent Boolean expression in the code for 3.6.6 and assign it to this variable called both De Morgans. And I'm getting that information from the assignment itself. So looking right here, your resulting Boolean expression. Oh, right here. Convert it and then assign it to its own variable called both odd De Morgan. And basically what this is going to do is that the code is going to check that both of these have the same results each time. Okay, so here's what we're going to do. We're going to go and collaboratively do this. Really, we only have one thing to change. Oops. So it's not going to be as interesting as maybe some of the other ones where we have several lines to change, but let's go ahead and I think on this next slide, yeah. So on this next slide, we have a link to implement that solution together. Let me open that up, and if you want to come on over, we can do that together. Oh, some of you are already there. Hello. Okay. So I see Kay is already there. Let's see, Kay. Since you're um, so hyped to do this, because you're like the first one in here before me. Yes, thank you. All right, so she's going for it, and she is typing in, let's see, what was the variable name? Both odd De Morgan, this one right here. That's the name that you can use. All right, let's try that out. Let's go ahead and let's run this. I know when I run it on my side, you don't see it, so you can go ahead and run it as well, or just come on over to my shared screen. I'm gonna type in, let's type in two odd numbers. Let's do 3 and 5. They're both odd and they get the same results. What about an odd and an even? Let's do 1 and 2. Okay, awesome. That works too. And then we'll do an even and an even. Okay, cool. Let's see. I'm noticing, let's see, let's try the odd and the even again. I'm seeing that I'm not always getting this printed out, and I think I see why. Can anyone see maybe what is a little bit different than what we came up with? Looking back at the slides, oops, it's a little bit different if you look at how, uh, like where the negation is. Yeah, almost. Yeah, there we go. We want to negate the whole thing instead of each component. Yeah, and then we'll group those together. So let's try that out again. Let's run it. Oop, what happened? Line 18. Yeah, it's there. Maybe it wasn't there. Okay. Let's see what we got. Okay, so we've got not. Ah, I see. Let's add in that parenthesis right there. There you go. Okay, it was just terminating early. So let's go ahead and run it again. Okay. Sometimes I like to space things out to really visually see. It makes it easier to see each component. So let's try 1 and 1. Okay, cool. We got the message. It's going to print out De Morgan was right again when both of our Boolean expressions, both odd and both odd De Morgan, are giving us the same result. So that's what we want to see for each combination. So we did odd and odd. Let's do odd and even. Cool, we got that message also. And then let's do even and even. Cool, we got the message again. And then just to make sure, let's do, I think we did odd and even. Let's do even and odd. Cool. So that checks out. So again, you can use this solution for, what is it, 3.6.6 if you want to copy and paste that in. We do have just one more assignment. Let's see. Let's see what we got. So this one is a is more of a debugging problem. So if you want to attempt this one, I know that we have some time left, but I just don't want to worry about going over time. If you want to attempt this one on your own, 3.6.7, we can definitely pick up where we left off on Monday and go ahead and solve this one together as well.